Hi, this is going to be a brief review video of everything that's going to be on the test. So let's do least common multiple first. So the least common multiple, if you get two terms like x minus 3 and x squared minus 9, what you're going to do to find least common multiple is break them down into factors. X minus 3 can't be broken down any further. X squared minus 9 can be broken down to x minus 3 and x plus 3. And then what you do is you find a way to sort of morph everything together. Like this x plus 3 occurs twice, but it only needs to occur once. And what I mean by that is x minus 3 times x plus 3. This would be the least common multiple, whatever this multiplies out to. Because by having that x minus 3 in there, it sort of is morphed into the whole equation. The idea of finding least common multiple is to break down all the factors and then to just morph them in accordingly. Yeah. Next, we're going to have... let's do cross multiplying because just want to let you know when it's okay to cross multiply. So cross multiplying in a situation is sort of like untying a knot, because it kind of, the whole thing even kind of looks like a knot, because you got this side and the equal sign in the middle, and you're like crossing over. It looks like you're untying a knot, and you are, because you're simplifying everything. And I'm just going to algebraically justify this. So this is how it would work. You would multiply c over d by b over b. And the reason why you would do that is to get the same to get these two fractions to have the same denominator in order to simplify it. And b over b is technically 1 because it's a number over itself. So you're changing the orientation without really changing the value of the number. So that goes down to bc over bd, because the numerator has to be multiplied too. And then a over b, in order to get the same denominator as this fraction, would have to be multiplied by d over d. And then you would get AD over BD. And that's your new thing. And these two fractions are equal to these two fractions, but just because they've been multiplied by different ones, because this is 1 and this is 1, their value hasn't changed, but their orientation has. And now these two fractions have the same denominator, so you guys just got to multiply by BD on both sides. And you get AD equals BC. Now the great thing about this is that you don't have to go through all these steps, because it turns out AD and BC are just the pairs from cross multiplying. So that's why cross multiplying is okay. That's why untying this knot is okay, because there's a whole process of getting the two fractions to have the same denominator and then multiplying them by each other and then getting this. Okay, so on the review sheet, and I'm assuming on the test, let's hope so, that there's going to be a lot of factorization and factoring things out. So there's just a few shortcuts, or just a few things that are necessary to know when it comes to squares and cubes and stuff. So that comes to the okay, well, let's just do the first. So let's do the first rule that you know. A squared minus b squared equals a plus b times a minus b. So that's a quadratic function that will appear frequently. So if you see x squared minus 4 anywhere in parentheses, you should consider that equal to x plus 2 times x minus 2. Because x squared is x squared and 4 is 2 squared. This will not work for anything like a squared plus b squared. It won't work. Won't. It just won't. Because when you have the way it works is that you know how like you have three terms. It's like ax squared plus bx plus c, and the thing is this in a quadratic function with these three terms, the b here is going to be the sum of these two numbers, and the c is going to be the product of these two numbers. So the last number is these two numbers times each other, and this thing is these two numbers added to each other. And if you get plus bx, if you get a squared plus b squared, it has no relevance to something that would omit this term. The reason why this works for the difference of two squares is that this term gets cut out by plus b and minus b canceling one another out and just getting rid of this middle term. That's why it won't work for the sum. Sorry if that was confusing. Now let's do a cubed plus b cubed. Now what that comes out to is a plus b times a squared plus minus ab plus b squared. And a cubed minus b cubed comes out to a minus b times a squared plus ab plus b squared, I think. Yeah, that's what it comes out to. So, for example, if you had x cubed minus 8, you would turn that into, since x cubed is x cubed and 8 is 2 cubed, you would turn that into x minus 2 times x squared minus 2 times x, 2x, plus 2 squared, which is 4. And that's what you would get for that. The intuitive way for me to think about this is that for the sum, you start with a sum and then you go into this thing being negative. And then with the difference, you start with the difference and then you go into the thing being positive. So it's sort of like you start off with what it is and then you go to the negation of that. And by the negation of that, I only really mean like whether this middle term is positive or negative. Yeah. With any problem, that's any problem ever. I went over this in my last video, but if you have a problem like the one on the review sheet, 3t minus 1 over 3t equals 2/3. This is I'm doing a problem now, basically. So the way that I like to do a problem is by finding the least common denominator in the problem. The least common denominator is the least common multiple of the denominators. So you'd get you would do the thing that we did before on here with the least common multiple with like finding out all the factors. So you have t, 3t, and 3. You have 3 and t here, 3 and t. So there's no need to repeat anything. So the least common multiple of all of these denominators is just 3t. And that's the least common denominator in this whole problem. So you find the least common denominator in the whole problem, and then you multiply the whole problem by it, 3t. And then the reason why that's useful is you do 3 over t times 3t. That cancels out the t, and you get 9 minus 1 over 3t is just 3. So that's just 1. And then 2/3 times 3t is equal to the 3 gets canceled out, so that's 2t. So this is the new equation that you get. And the thing about this is that this can just be algebraically solved. This just turns into an algebra equation. 9 minus 1 is equal to 8, 2t, divide by 2, and you get 4 equals t. So that's why finding the least common multiple is important here. Because in order to solve an equation like this, you have to find the least common denominator and cancel everything out. Yeah. Alright, I think I've gone over most of the things that you need to know for this test. There are some really big multiplying problems, but I think the rules I went over with like x squared minus 4, x cubed minus like 2 cubed, like the sum and difference of the squares and the cubes should be able to get you to a point where you're good. I think I also did a video about the fractions within the fractions. I think what are those called? Like not inbred fractions, but like they're called something. I did a video on that too. So there's a few videos if you want to study. That's it.